In this lesson, I'm going to teach a piece of information about array comparative genomic hybridization or Array-CGH technique. In another lesson, I teach CGH technique that you could find it in my channel. There is a subtle difference between Array-CGH and CGH. As I mentioned before, CGH is a very good technique to compare alteration between a solid tumor tissue and a normal or a reference tissue. Because, as I mentioned, in solid tumors, karyotyping is not a good method because of some reasons that I tell about in another video. The difference between Array-CGH and CGH is the usage of the reference or the normal spread of metaphase chromosomes in CGH, but using probes that are attached to a DNA chip in Array-CGH. So the difference is replacing a metaphase spreads by probes attached to a DNA chip. In array, we have a very good resolution. In CGH array, we have the same data as CGH, but in a very high resolution picture. In CGH, we have a metaphase spread. This spread used as a reference DNA for attaching to cancer DNA and healthy DNA. This kind of DNAs with different dyes competing each other to attach to the metaphase DNA or metaphase chromosome. So if in a region test DNA or DNA from tumor cells could attach more than reference or test DNA, we have an elevated green to red ratio, for example in this example. So we can realize that in this region there are a duplication in the solid tumor. Because of this duplication, the representative DNAs of this region are more in cancer DNA than in reference or in healthy DNA. But this kind of attaching produces a very vigorous or a very dense signaling. So in some cases the real duplication is here, for example, just here. But the vigorous signal and the dense signal spread in a very big region. So we realize that there are a duplication in a vast region, for example this region, but the duplication is a very tiny region here. But we misunderstanding, and we have a very low resolution. Never we can realize that the duplication is restricted to this tiny region. But in ArrayCGH we don't have metaphase chromosome spreads. Instead of, we have some probes as a representative of all the genome on a DNA chain. For example, we have a probe representing this region, a probe representing this region, a probe representing this region, a probe. We have many probes that are representing all a chromosome, all the chromosome in a genome. But because these probes are not attached to each other and they are separated in some spots on an array. For example, this probe is here in multiple copies, the same copies. These probes are here in same copies. This probe is here in same copies. So we have all the regions, but in separated spots. This spot is related to this region. This spot is related to this region, and so on. We have all the representative probes that are covering all the genome. Chromosome 1, 2, 3, chromosome X, or maybe Y. But in separate spots. So if we have a tiny region on a genome of a cancer tissue, for example, in this region, in normal CGH, when the probes, when the tumor DNA that are representative of this region from a patient are attaching to this region, we have a very vigorous, we have a powerful signal because of their amount, their plenty of them. So we have a misunderstanding, and we realize that this big region is the originate of duplication. But in ArrayCGH, when we have a separated spot, for example, imagine that a probe that is a representative of this region is separated, for example, here, many copies. Then we have a little test DNA, but a large amount of, we have a little reference DNA, but a lot of test DNA in here because of the duplication in tumor tissue, we could understand that the duplication is restricted just to this region, just this region. So we have a very high resolution, and we don't misunderstanding the real region that is the mainland of duplication or deletion too, as well as the duplication we could interfere the deletion, interpret the deletions, and the size of the probes. For example, some ArrayCGH have probes that are ranging from 5 to 10, for example, KB, or some of them from 100 to 200 KB. With the size of probes, we could change the resolution. For example, when we have very tiny probes, very small, very short probes, we could have a very high resolution. So ArrayCGH, in the same principle of CGH array, is working, but because of having many probes, many small probes, it could provide us a piece of information with very high resolution. If you want to realize the impact and the importance of ArrayCGH, I recommend you to see and watch carefully another video that I taught some tips about CGH. Have a good time and goodbye.